Good day, I am Borja from Bsit 2103. For today's video, I am going to answer the activities in chapter 4. First, the activity 4.1.35 entitled Physical Layer Terminology. Instructions. Descriptions of the physical layer are provided in the table. Drag each physical layer term to its description. The first is media that uses patterns of microwaves to represent bits. I think this is wireless. The capacity of a medium to carry data. I think this is bandwidth. Media that uses patterns of light to represent bits. I think this is fiber optic. A measure of the transfer of bits across the media. I think this is throughput. Media that uses electrical pulses to represent bits. I think this is copper. So let us check if my answers are all correct. All of them are correct. So I will discuss each of them. Wireless. A wireless network allows your business to provide secure wireless access to the internet for guests such as customer or business partners. Bandwidth. The bandwidth command is only there to communicate the speed of the interface to higher level protocols. Most of the time, a routing protocol needs to know the speed of the interface so it can choose the best route. In the case of routing protocols, IGRP, EIGRP, and OSPF all use the bandwidth statement. However, TCP will also adjust its initial retransmission parameters based on the bandwidth configured on the interface. The third is fiber optic. Fiber optic cables are the medium of choice in telecommunications infrastructure, enabling the transmission of high-speed voice, video, and data traffic in enterprise and service provider networks. The fourth is throughput. Throughput is the amount of packets per second or MBs per second that a device can process. So each device has a set of amount of throughput it's able to push through. The more service you turn on, the less the throughput becomes. The last one is copper. The copper ports page displays the result of integrated cable tests performed on copper cables. The tests use time domain reflectometry or TDR technology to test the quality and characteristics of a copper cable attached to a port. Cables of up to 100 meters long can be tested. This is the second activity in chapter 4.2.7 entitled Copper Media Characteristics. Instructions. UTP, STP, and coaxial copper media characteristics are provided in the table. Click the appropriate field to match the characteristic to the media type. First, attaches antennas to wireless devices can be bundled with the fiber optic cabling for two-way data transmissions. I think this is coaxial. Counters EMI and RFI by using shielding techniques and special connectors. I think this is STP. Most common network media. This is UTP, and the last terminates with BNC, N type, and F type connectors, and I think this is coaxial. Let's check if my answer is correct. All of them are correct, so I will explain each of them. Copper cabling, the characteristic of copper media. Networks use copper media because it is inexpensive, easy to install, and has low resistance to electrical current. However, copper media is limited by distance and signal interface. Data is transmitted on a copper cables as electrical pulses. Copper media. There are three main types of copper media used in networking. First is the unshielded twisted pair or UTP, shielded twisted pair or STP, and coaxial. These cables are used to interconnect nodes on a LAN and infrastructure device such as switches, routers, and wireless access points. Each type of connection and the accompanying devices have cabling requirements stipulated by physical layer standards. Different physical layer standards specify the use of different connectors. These standards specify the mechanical dimension of the connectors and the acceptable electrical properties of each type. Networking media use modular jacks and plugs to provide easy connection and disconnection. Also, a single type of physical connector may be used for multiple types of connections. For example, the RJ45 connector is widely used in LANs with one type of media and in some ones with another media type. Unshielded twister pair or UTP cabling is the most common networking media. UTP cabling terminated with RJ45 connectors is used for interconnecting network hosts with intermediate networking devices such as switches and routers. Shielded twister pair or STP provides better noise protection than UTP cabling. However, compared to UTP cable, STP is significantly more expensive and difficult to install. Like UTP cable, STP uses an RJ45 connector. Coaxial cable, or coax for short, gets its name from the fact that there are two conductors that share some axis. A copper conductor used to transmit the electronic signal. The copper conductor is surrounded by a layer of flexible plastic insulation. Coaxial cable was traditionally used in cable television cable capable of transmitting in one direction. It was also used extensively in early Ethernet installation. This is the third activity 4.2.2.6 entitled T568A cable pinouts. Instructions. Correctly align the wire colors to build a TIA or EIA 568A cable pinout. Rug each wire color to its correct placement of the RJ45 image in the graphic. The first one is this. The second one is this. The third one is this. The fourth one, the fifth one, the sixth one, and this. And the last one is this. We will see if my answer is all correct. All of them is correct, so I will discuss. So, what do you think is the difference between T568A and T568B? We also need to answer this T568B. first one, the second one, the third one, this one, the fourth, no, this is the third, the fourth, the fifth, the sixth one, the seventh, and the last one. Let's check. All of them are correct. So I will explain the difference between them. T568A and T568B are the two color codes used for wiring 8-position RJ45 modular plugs. Both are allowed under the ANSI, TIA, and EIA wiring standards. The only difference between the two color codes is the orange and green pairs are interchanged. T568A wiring pattern is recognized as the preferred wiring pattern for this standard because it provides backward compatibility to both 1-pair and 2-pair USOC wiring schemes. The T568B standard matches the older ATA and T258A color code and the most widely used wiring scheme. It also permitted by an ANSI/TAI/EIA standard, but it provides only a single pair backwards compatibility to the USOC wiring scheme. The colors are white green, green, white orange, blue, white blue, orange, white brown, and brown. This is the fourth activity in chapter 4.2.37 entitled Fiber Optics Terminology. Instruction. Descriptions of fiber optic media are provided in the table. Click the appropriate field to match the description to the fiber optic cable type. The first one is can help data travel approximately 1.24 miles or 2 km or 2,000 meter. I think this is multimode. Uses light emitting diodes or LEDs as a data light source transmitter. I think this is also multimode. Uses lasers in a single stream as a data light source transmitter. I think that this is a single mode. Used to connect long distance telephony and cable TV applications. I think this is single mode. Can travel approximately 62.5 miles or 100 km or 10,000 meter. Used in a campus network. I think this is multi-mode and this one is single mode. Let's check if my answers are all correct. All of them are correct, so I will discuss each of them. Fiber optics is sending signals down hair thin strands or glass or plastic fiber. The light is guided down the center of the fiber called the core. The core is surrounded by an optical material called the cladding that traps the light in the core using an optical technique called total internal reflection. Single mode fiber optic cable. Fiber optic cable has a small diametral cord that allows only one mode of light to propagate. Because of this, the number of light reflections created as the light passes through the core created or decreases, lowering attenuation and creating the ability for the signal to travel farther. This application is typically used in long-distance, higher bandwidth runs by telcos, KTV companies, and colleges and universities. Multi-mode fiber optic cable has a large diametrical core that allows multiple modes of light to propagate. Because of this, the number of light reflections created as the light passes through the core increases, creating the ability for more data to pass through a given time. Because of the high dispersion and attenuation rate with this type of fiber, the quality of the signal is reduced over the long distance. This application is typically used for short distance data and audio or application in LANs, RF broadband signals such as what cable companies commonly use cannot be transmitted over multi-mode fiber. Activity in Chapter 4, which is in 4.4.3, entitled Generic Frame Fields. Instructions. Drag the generic frame field to its correct location on the diagram. The header is in this. The second one is the packet or data. The third one is trailer. And on this, the first one is the frame start. Second is addressing. The next is type. Next is control. Next is data, error detection, and the frame stop. We will check if my answers are all correct. It seems that all of them are correct, so I will discuss some of them. Frame fields. Framing breaks the stream into separable groupings with control information inserted in the header and trailer as values in different fields. This format gives the physical signals a structure that can be received by nodes and decoded into packets of the destination. First one is the first frame start and stop indicator flags used to identify the beginning and end limits of the frame. The second is addressing, indicates the source and destination nodes on the media. The third one is type, identifies the layer 3 protocol in the data field. The next one is control, identifies special flow and control services such as quality of service or QoS. QoS is used to give forwarding priority to certain types of messages. Data linked frames carrying the voiceover or VoIP packets normally receive priority because they are sensitive to delay. Data contains the frame payload. Error detection. These frame fields are used for error detection and are included after the data from the trailer. And we will try this one. The part 2. The instruction. Drag and drop the generic frame field to its description. The first one contains the IP header, transport layer, PDU, and data. This one is data. Identifies the layer 3 protocol used by the LLC. This one is type. Marks the end of the frame. Frame stop indicator flag. Identifies source and destination host by MAC address. I think this is addressing, and the last one is special flow control services. I think this is control, and let's check if all of them are correct. So, thank you for watching and God bless.